So we've done a couple different things in this section. The first couple problems are like yesterday's when we were evaluating our limits. And remember, the whole premise on these, we know if we can get it to be limit of sine theta over theta, when theta is approaching 0, that turns into 1. And that's true as long as the argument and the denominator are the same and they're approaching 0. So when I look at this, we have to rewrite it. One thing that I'm noticing, when can I stop writing this limit symbol? When I substitute it in. You guys are getting lax about that again. So write your limit up until the point when you substitute it in. It does make a difference, and there will come a time where you forget and it gets really confusing. So please write that limit. How would I separate this one? I can't just evaluate because I'm getting 0 on top and 0 on the bottom. So what would we have to do?
Separate the sine 3 of x and sine 5 of x and x.
Okay. You can pull apart the top and the bottom x squared, they each get an x. For my property to work, this has to be sine 3x over 3x. So I need a 3 on the bottom. We can't just add a 3 on the bottom, we have to put 1 on the top as well, so it would cancel. I don't need it, so I'm just pulling it over to the side. So this is mathematically equivalent to what we started with. Sine of 5x over x, so I would have to put a 5 on the bottom, which means I need another 5 on top. So then if x is going to 0, sine of 0 over 0, that's going to 1. Sine of 0 over 0, that's going to 1. Times my 3 times my 5. And I get 14.
That as well. What are we talking about? Oh, to show you wearing to school. Good job, though. Good job.
Alright, so if I look at this one, can I just plug in my 0 to start with? I would get tangent of 0, which is 0, over sine of 0, which is 0. So 0 over 0, we can't evaluate. So what would we do? Tangent of sine over cosine. So I have that whole thing divided by sine. This is like a sine t over 1. So if you want to divide fractions, you can multiply by the reciprocal. What would I do now?
Separate the cosine and sine from theta.
Okay. Let's take this cosine off. We can pull it over here. Now, if I want this to be something I can use my property on, I have to first have a t on the bottom, right? If I add a t on the bottom, I have to put a t on top somewhere, and the best place would probably be right here, because this one needs a t as well. So those t's would cancel each other. This has to be a sine of 6t over 6t, so I need a 6 on the bottom. Does this one need a 6 on top? No, so let's just pull the 6 over here. This one, it's sine of 2t, so we need a 2t here. So if I put a 2 on the top, we need a 2 on the bottom. So I'll pull it over there. So at limit as t approaches 0, sine of 6t over 6t, that goes to 1. We talked about yesterday why the reciprocal would also be true, so that is also going to 1. This is 6 over 2 times the cosine of 0 is 1. So we get 6 over 2, which is 3. Any questions there? So that's what we were working on yesterday. Let's go back and do some more derivatives of trig functions. You are going to have to learn these. At the bare minimum, you have to know the derivatives of sine and cosine. All 6 would save you a lot of time. Worst case scenario, the others, you could always write them in terms of sine and cosine and get there, but it's going to take longer. So it's better to know them. Here, I have a cosine x over 1 minus sine x. So I have an x on both top and bottom. What would I have to do to get the derivative?
Take the derivative. Would you separate it first?
I wouldn't separate it. We have 2 things being divided.
Oh, the quotient.
Quotient rule.
Oh, gosh.
So quotient rule is low d high. What is the derivative of the top? The derivative of cosine. Negative sine. All the cos have a negative derivative. Minus high. D low. What is the derivative of 1 minus sine x? So the derivative of 1 is 0 minus the derivative of sine is cosine, so we get negative cosine x over low squared. Right, so then if we distribute, I get negative sine x. Negative sine times negative sine would be plus sine squared x. Negative cosine times negative cosine would be plus cosine squared x. Over 1 minus sine x squared. Most important trig identity. What is sine squared x plus cosine squared x?
Mm.
So then negative sine plus 1 is the same as 1 minus sine. So I can cancel the 1 minus sine on top and bottom, so I get 1 over 1 minus sine x. Why don't you guys try this one?
The product.
Product rule. We have 2 things being multiplied. Yeah, I know it's product because they both have x's. If it were just like a 5 cotangent of x, then I wouldn't have to do the product rule because there's only one x in the product. So, our derivative. Derivative of the first one. What's the derivative of 5x cubed?
15x squared.
Times the second. Plus the first. Derivative of the second. What is the derivative of cotangent?
Negative.
Tangent and cotangent have similar derivatives. All the cos have a negative derivative. So derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared. Alright, so then we multiply, we get 15x squared cotangent x minus 5x cubed cosecant squared x. And that would be all we could do. That's our final answer. How are we doing on these? Let's practice a couple more. The last two for today. G of y, that tells me y is the variable. Secant of y times tangent of y. So, this is two trig functions. They both have a y in them, so we have to do the product rule. Derivative of the first. What is the derivative of secant?
Secant is tangent.
Except this time it's y, so secant y tangent y. So that's the derivative of the first one times the second plus the first. So my first one is secant y times derivative of the second. What's the derivative of tangent?
Secant squared.
Okay, tangent y times tangent y would be tangent squared y. Over here, secant times secant squared would be secant cubed y. You could factor out a secant if you wanted, but there's really no benefit to it. I just expect you to do basic multiplication and combine like terms. All right. Is that okay? Last one. Do I have to do product or quotient here? No, because I don't have, the only thing being multiplied is a 3 with a cosecant. They both don't have a variable. So when I do the derivative, that -3 just trails down. So what is the derivative of cosecant?
Negative cosecant, cotangent.
So it's -3 times that, or you could go ahead and change it to a 3. Plus derivative of cotangent.
No, cosecant squared.
So we just get 3 cosecant x cotangent x minus cosecant squared. All right, any questions?